We are live now. You can start.
Thank you. Hi, everyone. Welcome back to our second workshop as part of the end of the year hackathon. And if anyone was not here yesterday, we went through the basic use cases of request network. How does it work? How to start creating requests and paying requests. As well as we had a general overview on the advanced payment networks, the web components as well. And I think we have the recording from that session as well, if you guys want to go back and see that. If not, everything that we mentioned yesterday would be here in the docs as well. So to start today's session, we will go through a bunch of advanced payment networks, starting with the single request forwarder. So in order to understand the single request forwarder first, we need to understand how does request network handle payments and the reconciliation of payments. So when a request is created, we generate a payment reference that is linked between the payment as well as the request. And once you make a payment, a function call is made to our smart contracts that does forward the payment to the person that needs to receive the money, as well as release an event. By releasing an event, we can index that event and have a reconciliation between the invoice and the payment themselves. But the issue that can arise here is that since we have to do a function call, it is not possible to just transfer the funds directly from a normal wallet into the smart contracts to make a payment. Centralized exchanges, you cannot pay from centralized exchanges either. And sometimes people do not want to connect their wallets to websites they do not know and make signatures. So that is where the single request forwarder comes in. A single request forwarder is unique to each request. So when a single request forwarder is deployed, it takes in the necessary information that a request needs to make a payment, such as the payment reference, the payee address, as well if there is any fee amount and fee address. Those are all stored in the single request forwarder. They're stored as part of the deployment. They would not change. It is not possible to change them afterwards. So with that being said, each single request forwarder is unique and linked to a specific request, hence the single request in the name. And with that, we would be able to then make transfers directly from our wallets to the single request forwarder or from centralized exchanges and be able to pay the requests we create without having to make an actual function call. And the key benefits here as well is that it is compatible with normal transfers, as I mentioned earlier. If you have a smart contract as part of your project, you would not have the need to change the smart contract in order to integrate Request Network. All you need to do is instead of sending the funds directly to the receiver, you would send them through the single request forwarder, which already has the receiver address, and it will do the forwarding between your smart contracts and the receiver. As well, as I mentioned earlier, it is friendly with centralized exchanges where you can transfer the funds directly from the centralized exchange to the single request forwarder, and this would allow for the payment of the single request proxy. Now, to understand how we can work with a single request forwarder, it's pretty straightforward and simple. All you need to do is create a request, which is the first step in either way if you're using the single request forwarder or not using it. And then you would pass in the information, the necessary information from the request to the deployment of the single request forwarder, and this will deploy the smart contract for you. And then after the deployment is done, you would just need to send the funds and you will be able to pay invoices. We have an integration guide here where you can create a request. We have a specific page for that. And we made it as easy as possible to start using the single request forwarder, where we created some functions in our SDK as part of the payment processor, where all you need to do after creating a request is pass in the request data and a signer, and this would allow you to deploy a single request proxy. This method will automatically know based on the request data if it needs to deploy an Ethereum single request forwarder, which means it accepts native currencies depending on whichever chain it is on, or an ERC20 single request forwarder, as well as take the necessary information such as the payee, the payment reference, and the fee. So this makes it as easy as possible. And we also have another function that allows you to pay with a single request forwarder if necessary. I've mentioned earlier how easy it is to transfer the money through a wallet to the single request forwarder. So now we've done the theory, we can do the work ourselves. Here we have some of the code that we went through yesterday with the steps of generating the signer and creating the single request network instance, preparing the request parameters in order to create a request. And we can see here that we have a request on Sepolia for ETH with the amount of 001 ETH. And then all we need to do is pass in the parameters to create a request, and then we can get our request ID. But now we will have this extra step of deploying the single request forwarder and then seeing how it would work and interact with it. So by opening a new terminal, I can just run this script. And this will start by initially creating a request for us, which we can, again, open in request scan. Here we can see all the details of this current request we just created. It has 001 ETH and it was created 17 seconds ago. Now, if we go back to our code, we can see that the forwarder has been deployed for us. And if I just open my MetaMask and forward 001 ETH to that address, sorry, that was 0 ETH, 0.001 ETH to the single request forwarder address that we just got. And let's open the transaction. It will take a bit of time for the transaction to finish, but once it is done, you'll actually be able to see all of the steps that the single request forwarder would take to make the payment. And once we go back to request scan, we would be able to see that our request has been paid. So now, as we can see that it is paid now, and the payment happened 41 seconds ago with our transfer. Let me refresh the transaction and see. Yes, now we can see that we had a 001 transfer from our single request forwarder to our fee proxies, which are the smart contracts responsible for making the payments. And those fee proxies then forwarded our funds to the receiver. And just like that, you would be able to start using the single request forwarder and accepting payments with invoices without having to have the interaction of connecting the wallet and signing transactions. Just a normal transfer would suffice. It is worth noting, though, since this is a smart contract deployment, it would take up some funds to deploy the smart contract. So that is just a small warning there. We would love to see as many implementations as possible that can implement the single request forwarder in this hackathon. Moving on, we can now see some other advanced payment networks. We can go to, in our documentation, we have a protocol overview payment network section that would have all the details for our advanced payment networks. You can see here we have a long list of possible payment networks. We won't be able to go through all of them today, but all the information are written here. And if you have any other questions on top of that, we're always available on Discord where you can reach out for questions. There are two different types of payment networks. We have reference-based payment networks where automatic reconciliations would happen by linking the payment to the corresponding request. So you won't need to do any manual work to reconcile and tell that this request has been already paid. As well as there are declarative payment networks, which we'll get to later, where you would have to manually declare that the payment has been made as well as received on the receiver side. Starting with the reference-based, we've already went through ERC20 fee proxy as well as the native payment fee proxies. These are the most basic payment types where you would either have an ERC20 or a native request where you have to specify which network you're on, the currency you want to receive payment on. For example, this one is USDT on Ethereum, the amount, and you would be able to create a request. It is very similar for the native as well, whereas the value is ETH instead of the address. It is worth mentioning that the ERC fee proxy contract also allows to add a fee address and fee amount. So in the case, for example, where you have to create a request, the platform, as a platform owner, for example, you can pass in a 10% fee for each payment. And that way, whenever a payment happens, automatically you will also receive a fee on top of the request itself. Similar thing can happen with ETH fee proxy. We also have any TRC proxy contract. This means it's a conversion payment, meaning that you can denominate the request with a currency and then receive the payment in a different currency. The main example here, where you can have the request and an invoice in USD, but receive the payment in tokens like USDC and USDT. The way it works is we need to specify the payment network as any TRC20 proxy and have the fee amount. And we also have to pass in the accepted tokens. For example, it can be here USDT and USDC. In this example, it's DAI. And the max rate time span is 1,800. This is necessary because at the moment of payment, using oracles, we would get the prices and we would get the prices from the price feed, and the conversion happens at the moment of payment. In the request info, we can see that our value for the currency is normal USD. So what this means is that our request is created and denominated in 10,000 USD, but we get paid in DAI. There is also a very similar contract for ETH proxy, where you would receive the native tokens instead of an ERC20. We also have a very interesting payment network as a transferable receivable. This allows you to create a request and have it as an NFT. So, and the NFT can be transferred or sold as it is mentioned here. And the owner of the NFT is the one that receives the payment. This would be a very good use case in the example of invoice factoring, where you can create an invoice, sell it to a third party at a certain price, and then the NFT is transferred to them. And them being the owners now, when the invoice is paid, all the funds go to them instead of the original owner. In order to use transferable receivable, we need to mention the payment network ID as ERC20 transferable receivable, have the parameters as well as the expected amount. This is very similar to how we would have any other request, but by just changing the ERC20 to transferable receivable, that will allow us to have our request as an NFT. Then we have declarative payments. Declarative payments are, as I mentioned earlier, manual. So when you create a request, you would be able to declare them as paid or as received or cancel them. And it is worth noting that all of the reference-based payment networks are built on top of the declarative payments. So even the reference-based payment networks can be declared as paid or payment sent. And then on top of that, we can have the automatic reconciliation. But the option is there just in case if the smart contracts would fail or something happens and the network is no longer working, the declarative option is always there. If we just want to create a pure declarative, on the other hand, we can just have the payment network ID as declarative, and we can have the value here of the currency. In this example, since we're expecting the currency to be fully in fiat, and there is no way to have automatic reconciliation, at least on chain, we have it as purely declarative. And the way it works is that after a request is created, for example, here, we can just go to the request and declare. We have specific functions such as declare received paid and declare received payment, sent payment, and sent refund. So each party of the request, since there are two parties, the person that creates the invoice as well as the receiver, can declare the invoice. And once both parties have declared, for example, either payment sent and payment received, then the proxy will and the request will automatically be declared as paid automatically. When you make a declaration, a new piece of content is written to IPFS in the addition to the request, and that would allow us to see each declaration and each event as it happens. We also have meta payment networks, which allows us to specify multiple potential payment networks for a single request. And this would allow us to just specify as many payment networks as we want, and then the payment can be settled with any one of those networks. We also support streaming, which would allow us to create a request with initial streaming value and starting date, and then it would trickle the payment as it goes, and it will automatically, based on the date and the amount, it will automatically know when the end date would be, and we can use that as well. Other than the payment networks, we can also, actually, before I move on to the encryption, I mentioned multiple payment networks, and it would be possible to check which payment networks are supported, because every chain does not support all of those payment networks. For example, we can see here that Ethereum has smart contracts deployed for all of our payment networks, but if I go to Base, for example, it does not support batch payment. So if you would like to go, oh, this is actually Sepolia. So Sepolia also does not support batch payments. So if you would like to know which smart contract is available on which chain, as well as the smart contract addresses, in our docs, we have the smart contract addresses section, and we have a table with each smart contract for each node. And if you want to learn more about the smart contract themselves, we also have a smart contract overview page where you would be able to see what each smart contract does. The protocol also supports encryption. So all of the creation of the request earlier I mentioned would be clear text requests. Anyone can go on request scan, for example, and see the data of the request. In order to make it secure, it is also possible to encrypt the requests when creating them. And this happens by using the public and private key pair in order to encrypt the request. And that way, only the specific holders and stakeholders of the request, meaning the payer and the payee, and other third party that can be added afterwards, but only those parties can decrypt the request and can see the information of the request. The way it currently works is that when you create a request, you provide the public key as an encryption, and keys are and they're used to encrypt your requests. Both the payer and the receiver have to use their key pairs in order to encrypt and decrypt. And when the request is being retrieved, you pass in the decryption provider with a private key, and that would allow you to decrypt the request and see the content of the request. And each workflow here is done separately. For example, this is about the encryption, where you provide the public key, and then the request is encrypted. And in terms of decryption, you have to provide the private key, and that way you would be able to see the content of the request. We also have a lot of guides in terms of how to update the request, for example, and swap to conversion, as well as meta payments that are worth going through. Here we have everything on how to do streaming payment and create a streaming request. For example, as I mentioned earlier, we can pass in the expected flow rate and expected start date and the payment address. And this would allow us to automatically assume the end date, and this will start the streaming process of the request. Yeah, that will be all in terms of the payment networks. If there are any questions specifically about the advanced payment networks or the single request forwarder, I would love to answer them. If there are no questions, please don't forget to join our Discord as well as our GitHub discussions. If you have any questions, we're always available there to answer all your questions. We have office hours. And yeah, we wish you the best luck in building with Request Network. Yes, we can end